Although nothing appears to be happening, all these substances are emitting nuclear radiation. It's invisible, but an easy way of detecting it is to use a Geiger-Müller tube attached to a counter. There are 3 different types of nuclear radiation: alpha, beta and gamma. Each has a different penetrating power. This is a beta source. It emits only beta radiation. The count rate is over 600 per second. Place a piece of paper in its path and the count rate falls only slightly. Some of the beta radiation has stopped, but most travels through. Replace the paper with a denser material and the count rate drops much further. Beta radiation is absorbed by a thin aluminium sheet. All nuclear radiation originates from the nuclei of radioactive atoms. When beta radiation is emitted, a neutron in the nucleus splits into a proton and an electron. The electron shoots out of the nucleus at high speed. Beta radiation is a stream of high-energy electrons. This electric arc is also a stream of electrons. See what happens when a magnet is placed nearby. Because electrons are charged, their path can be deflected by a magnetic field. The same would happen with beta radiation. So how does alpha radiation behave? This is an alpha source. At this distance, the count rate is about 500 per second. Place a thick sheet of paper in its path and all the alpha radiation is absorbed. When a radioactive atom emits alpha radiation, it loses an alpha particle from its nucleus. Each alpha particle is made of 2 protons and 2 neutrons. Alpha radiation consists of positively charged particles. How would you expect it to behave in a magnetic field? Cesium-137 is a source of gamma radiation. At this distance, the count rate is about 50 per second. Place a piece of paper in its way and nothing happens. A thin sheet of aluminium also has no effect. Gamma radiation is very penetrating. Several pieces of lead are needed to absorb this high-energy radiation. Unlike alpha and beta, gamma radiation is an emission of high-energy rays. It isn't made of charged particles, so won't be affected by a magnetic field.